Hello, in this video I'm going to teach you the basics of optimization modeling. Optimization is the focus of the first 2/3 of the decision models course. An optimization model is the way we frame a business problem in this course. An optimization model has 4 components. The first one is data. What is the information you have about the company and its problem? The second one are the decision variables, that is, the choices that the manager needs to make. The third one is the objective function, that is, what is the manager trying to optimize? And the fourth one are the constraints, what are the restrictions on the manager's choices? I'm going to ask you now to pause the video and go read the window glass case. It's easier to describe the features of an optimization model in the context of a problem. Okay, I'm going to assume you've read now the window glass problem. What is window glass's problem? Window has developed 2 new products. One is a new glass door, and the other one is a wood frame window. To build these products, Window is going to make use of 3 plants. It has access to a different number of hours per week in these plants because these are the number of spare hours available in the plant right now. Different products require a different number of hours in each plant. And the question that we want to address is, should we launch both products? And if so, what is the optimal product mix? The first ingredient of the problem is the data. So what is the data provided to us? The first piece of information provided to us is the profit per door and per window. We're given the information that each door is worth $300 and each window is worth $500 in profit. The next piece of information is how many hours do I need in each plant to produce 1 door and how many hours do I need in each plant to produce 1 window. And the last piece of information that we have is how many hours that we have available in each plant. In particular, we have 4 hours available per week in plant 1, 12 hours available per week in plant 2, and 18 hours available per week in plant 3. Now we're going to start building the other ingredients of our model. The first thing that we need to think about is what are our decision variables. The decision variables are going to represent the decisions that the manager has to make. In this problem, the decision variables can be represented by X for the number of doors to produce in each week, and Y for the number of windows to produce in each week. Once we have decision variables, we can establish an objective function. The objective function determines what is the manager's goal. That is, what is the manager trying to maximize or minimize? In this problem, the manager is trying to maximize the profit per week that the manager would obtain, which in this case it's 300 times X plus 500 times Y. And that's because each door is worth $300 in profit and each window is worth $500 in profit. An objective function could also be minimize some function of the decision variables. The last part of the model are the constraints. The constraints represent what are the restrictions on the manager's choice. In this particular problem, the restrictions are given by the plants. The manager can't produce as many doors as windows as he or she wants, but he or she can only produce according to the plant hours available. In particular, the number of doors that can be produced is at most 4, because each door takes 1 hour in plant 1, and there are 4 hours available of capacity in plant 1. Each window takes 2 hours in plant 2, and there are 12 hours available in plant 2, so our second constraint is 2y is less than or equal to 12. Our third constraint is given by plant number 3. Both doors and windows need to go through plant 3. And each door takes 3 hours and each window takes 2 hours. Therefore, the total number of hours that I'm going to need in plan 3 to produce X number of doors and Y number of windows is going to be 3X plus 2Y. And that has to be less than 18 because that's the total number of hours available that I have in plan 3. The other constraints that I need are non-negativity constraints. I need to tell my model that I cannot produce a negative number of doors or a negative number of windows. These constraints are easy to represent. They're just X is bigger than or equal to 0 and Y is bigger than or equal to 0. With this, we have a model. So what is our mathematical model? We have the decision variables X and Y. We have the objective function of maximize 300X plus 500Y, subject to the constraints that we discussed in the last slide. In the next video, we will focus on how to implement this model in Excel.